Welcome to Soil Sessions, a webinar series by the Soil Health Partnership. It is my pleasure to introduce our co-host for today's session. Dr. Sally Flis is the Senior Director of Agronomy with the Fertilizer Institute, where she focuses on the 4R Nutrient Stewardship Program at the national level. And Lisa Kubik is our SHP Field Manager in Eastern Iowa, where she supports growers with their on-farm soil health trial work. Today, Sally and Lisa will be sharing several farmer case studies that look at the interaction between soil health, conservation practices, and nutrient management. Sally, the floor is yours.
Thank you. This morning, I'm going to be talking about evaluating the cost of 4R practices changes on the farm. And just to start out with a little bit, who the Fertilizer Institute is. So we represent the fertilizer industry in the United States, everything from manufacturing to trucking to stewardship and sustainability on the ground. We are based in Washington, D.C., and a couple years ago, we were lucky enough to get to visit with Secretary Sonny Perdue at the Commodity Classic meeting with one of our 4R advocate farmers there, Maria Cox. Another piece that we work on is research, support for research and extension. And in the 2018 Farm Bill, we were able to get a new high priority research area indicated around working on nutrient management based on the source rate, timing, and placement of crop nutrients. And hopefully there'll be some funding to follow along with that soon as we look at possibly getting some appropriations bills rolling here. So that's just a little bit about who the Fertilizer Institute is. For those of you who don't know what 4R nutrient stewardship stands for, it's about selecting the right source of fertilizer or nutrients applied at the right rate, the right time, and the right place. All with the idea of trying to meet the crop needs at the right timing of crop uptake and limit the potential for environmental loss or for economic losses from applying nutrients when they're not needed. But 4R is more than just thinking about the source rate, timing, and placement of your nutrients. In order to make that source rate and timing and placement decision, you've got to consider things like the soil characteristics, any site-specific characteristics, slope, distance to water, conservation practices, type of tillage, type of crop, edge of field, cover crops, all of those types of things that can influence how or when you might want to apply your nutrients. Crop yield and quality goals. So for a lot of the land that we think about, it's really just the crop yield that we're focusing on. But when we get into thinking about the 4Rs for some of the specialty crops, like the picture on the screen here is a tomato grower in Florida. The quality of that crop is also really important to consider as we look at our 4Rs for nutrient application of both our macro and our micronutrients, because poor quality crop in tomatoes can mean you end up having to ditch your whole crop and lose money for the year. Additionally, looking at things like manure management, making sure those nutrients are credited for correctly as we're applying additional nutrients. What are the weather conditions? I've got a little picture here on the screen of soil temperature. Soil temperature is important to consider really in the spring, our spring and fall applications, making sure in the fall we're below that 50-degree threshold for soil temperature so that we're keeping any fall applied nitrogen in the soil, and in the spring making sure we're not applying or planting before the soil is warm enough so that we don't have a crop loss. And then finally the cost, which is probably the first thing a lot of people think about, is what's it going to cost to do these different practices. But if we don't consider all of the practices on the ground as we make our 4R decisions, we're not going to be as accurate as we can be with our nutrient applications. To go a little further on the question of cost, in 2017, the Fertilizer Institute did a couple of surveys. One was an online survey that went over a couple of days with both farmers and ag retailers, and the other was a phone survey to 200 farmers across the US, asking them what they knew about 4R and what it takes for them to make a practice change. And from both the ag retailer, crop advisor side and the farmer side, the number one thing they think about is how are they going to improve the farm operation profitability as they can consider different practices and different management options. And so the barriers to adoption that those in the survey also noted were the new equipment that might be needed? Is there a change in the labor or time that's needed? And do they maybe need to hire different outside expertise in order to make these changes happen on the ground? The top two sources of information on fertilizer management indicated in this survey were the agronomist or the fertilizer dealer, followed by other farmers. And that's where working with groups like the Soil Health Partnership is really important for us as the Fertilizer Institute, and part of the 4R program is having that farmer to farmer connection about what's working on the ground, what's not working on the ground, or research or outreach questions that may be arising. So what we did in order to help answer the cost question is we started working on case studies, and those case studies, there's about 13 of them right now that are on 4rfarming.org, with more to come as we work through getting them posted. You'll see we have a large variety there. We've got potatoes, we've got tomatoes, cotton, a bunch of corn examples. We've also got strawberries, I think, is our other sort of interesting one there. So the goal with the case studies overall is to create enough variety in those case studies that as a farmer or an ag retailer, you can go to 4rfarming.org and you can kind of look at them and see somebody who looks very similar to you and has tried practices or is trying practices that you're considering, and see how it worked for them. What did they use? How did they make? How long did it take them to make those practice changes? And what was that cost impact on the farm as they made those practice changes? So we've done this largely using our 4R advocates, and we've just finished, closed up our application round for our 10th year of 4R advocates for 2021. These are our 2020 advocates, and so we've got a couple, these guys up in the top are Minnesota sugar beets, corn grain, soybean, pretty diverse rotation. The longer picture here on the top, that is a 20,000 acre sugarcane and sweet corn specialty crop operation in Florida. And then we've got a orchard in Maryland, Delaware, Pennsylvania area where they're doing a lot of direct to consumer sales in their operation. This is a Missouri farm, corn soybean rotation. And then the last one on the bottom, the longer picture, is a cotton farmer in Texas where he's actually got, I want to say it's 20 or 30% of his acreage is in organic cotton production. So we're going to be able to look at that comparison a little bit in his production system. Looking at the details of a couple of what these farmers are doing to kind of see how we're already starting to look at that overlap of conservation and soil health practices and 4R practices. So this is a little bit more information on Maria Cox's farm in Illinois and her crop consultant, Kyle Lake, that was recognized with her when she won as a 4R advocate about 3 years ago now. So she's operating about 3,000 acres with her father. They do corn grain, soybeans, corn silage. They've got a cow-calf operation. They've been no-till since 1988, and they've started adding back in and playing around with strip till in some of their corn to figure out which way they want to go because of some of the nutrient placement concerns that they've had. In their soybeans, this is a couple years old now, but this is their cereal rye cover crop here in the picture. And they plant into a green standing rye. And then on top of that, the 4R practices that they're implementing for their soybeans are 2.5 acre grid sampling, variable rate prescriptions. All phosphorus and potassium is applied in the spring, and any manure that they're using on the farm, they are testing and crediting for as they adjust their nutrient applications. So yields in this management were about 71 bushels an acre in 2016, but they're also getting that cereal rye hay production as well out of this system. Looking at the corn management, so you can see here in the picture, this is a little bit of the strip till that Maria is working on. She has a great Twitter account. I would encourage you guys all to follow her on Twitter and see what she's doing. So they are also combining strip till and their cereal rye cover crop, but in their corn part of the rotation, they were terminating it at 10 inches instead of harvesting it for a forage crop like they're doing with their soybeans. As I mentioned, they're kind of going back and forth with strip till and no-till across different farms. And then where they're using hog manure to get good incorporation and reduce nutrient losses, they are doing a full tillage on those acres. Again, variable rate nitrogen, phosphorus, and potassium, and using nitrification inhibitors on any anhydrous ammonia that's applied, and trying to use split applications as much as they can in their system. So in addition to those, they've got a few other conservation practices that they're implementing as well. They've got some dry dams, some CRP acreage, buffer strips, grass waterways. And so this is a nice example of where they're really bringing together the 4R practices, conservation practices, soil health practices, and trying to figure out what works best for them to be sustainable into the future. So again, going back to our 4R advocates, as I mentioned at the few slides ago, 2021 is our 10th year of advocates. So when I have a new slide here, shortly after we select them, we're going to have 100 advocates and hopefully be pushing on 300,000 acres that are represented by those advocates. Currently, we're just over 215,000 acres that advocates are operating, and we've recognized in 22 different states across the US. And so we tapped these guys to help us figure out what does it cost to go from basic to advanced for our practices. So basic for our practices, a few years ago, working with a larger group of scientists and in conjunction with the International Plant Nutrition Institute, we created some practice tables to kind of plot out what's a basic, intermediate, or advanced nutrient management for our practice. So as you see here, as we go from basic to advanced, really rate is one that's a lot that we can do a lot with, and placement, that we're getting it below the soil surface, that we're splitting that application, we're using local adaptive management, we're using variable rate, we're using in-season sensors, that kind of stuff as we move to these more advanced nutrient management practices. And then what we were able to do, we've also got the Foundation for Agronomic Research, where the 4R Research Fund lives. As I mentioned at the very beginning, research and extension is an area that we really like to try and support and get behind to get more practices and better understanding of the practices on the ground. So currently we've got 6 projects in process across the country. One that is a multi-state project, that 2017 Nutrinet collaboration, where they're looking at reasonably close to the same 4R practices across that landscape, and all of the measurements that can be taken for nitrogen and phosphorus loss. So they're doing gas losses, nitrous oxide, they're doing surface and tile drainage runoff of nitrogen and phosphorus where they have tile drains installed, to really get an idea of what are all the loss pathways. And they're also doing soil health measurements there. So, and what are the soil health changes as they implement these things. One of the early projects, the meta-analysis there you saw listed at the beginning when the fund started, was looking at how does going from basic to advanced for our practices impact nitrous oxide emission, which is directly related to a lot of the food company, consumer packaged good company initiatives looking to reduce carbon emissions down through their supply chain. So if we can start recognizing farmers and giving them credit for reducing nitrous oxide emissions as part of meeting some of those carbon goals, there's some good opportunities there. So what was found in some work by Dr. Tony Vine at Purdue University was that nitrous oxide emissions respond to nitrogen management, and that it's related to the net nitrogen balance. And as we go from basic to intermediate practices, we can reduce our nitrogen balance by about 33%, which results in an additional reduction of about 7% in our nitrous oxide emissions. And then as we go from basic to advanced practices, we can get a 14% reduction in potential nitrous oxide emissions by the nitrogen management practices that we're implementing. So in order to take a look at both the environmental and the economic metrics in our case studies, we did 4 years of data collection at a whole farm level, or we looked at 4 individual fields over that same 4-year time period, depending on the diversity a lot of the time of the crop rotations present on the farm. We looked at the cost of all nutrient inputs and the equipment associated with any fertilizer application. And so a good example that I always use here is if the farmer's putting on a starter fertilizer, we count the cost of that tractor and that planter because there's a nutrient application happening there. If the farmer is not putting on a starter fertilizer, we don't count the cost of that tractor and that planter because there's not a nutrient application associated with it. So this is very specifically a budget or a calculation of costs just around nutrient management, really trying to hone in on that rather than confuse it with more of a partial budget. And it's also the same reason we didn't incorporate like a return on investment type number. We report yield, but we don't get into relating any yield increases directly to 4R practices, because we recognize that on these operations, there's a whole lot of things changing at the same time that are going to result in some of these yield responses that we've seen. So really just report yield to give readers of the case studies the optics of where does that farmer sit in relation to what may be happening on your operation. And the equipment costs that we use are either reported from the farmer or based on looking up similar equipment sizes, or based on a national database if it's equipment that exists in the some of the national databases that are available. Those databases also include the time and fuel use of that expected piece of equipment. And then the fertilizer price is based on those prices reported to the USDA. So to dive right into some of our results, this is an Illinois farm where we were comparing as they went from basic to advanced, also management based on grid versus zone soil sampling. So really the difference in price in their grid versus zone soil sampling is that there's a difference in that expertise or consultant cost for their grid versus their zone management. But what you'll see overall is that as they went from basic to advanced nutrient management practices on this operation, they were able to decrease their cost by $24 to $15 an acre when we get out to 2017. And they added things like multiple in-season applications. They're using inhibitors where it's most appropriate. They're variable rate applying phosphorus and potassium in their work. So to look a little more at the environmental metric side of this particular case study, you can see his yield across the top there. There is yield gain year over year, but as I mentioned, there's a lot of different management happening at the same time. So we haven't done really a yield response to 4R here. We just don't have that control over the system to say if that's what's happening. But the numbers I've got circled, so the nitrogen use efficiency, nitrogen balance, and the percent reduction in carbon emissions. So nitrogen use efficiency is a number that's pretty commonly talked about. That 1.2 pounds of nitrogen per bushel of corn produced is kind of that standard number that's always sort of been out there, and that's what we should be thinking about as we make our sort of fall planning, spring planning recommendations. But what we're seeing is that as farmers get more and more advanced with their nutrient management techniques, we're able to reduce or improve that nitrogen use efficiency per bushel of corn. And he's getting down in 2017 to 0.8 pounds of nitrogen applied per bushel of corn. In the next slide, I'm going to talk a little bit about why that might be getting more efficient than we want to be, especially as we're thinking about the soil health aspects of increasing soil carbon and function and organic matter and biological activity in the soil. Nitrogen balance is negative. That's a number that is talked about as a number to use to measure are farmers going in the right direction with nitrogen management on their field, and are they reducing nitrogen losses, primarily around surface losses for that number. Again, you can see it's negative, and as I'll discuss a little further in the next slide, we could be getting into some areas where we don't really want to be if we're really trying to build whole system sustainability. And as we get down to that last line, you'll see that the CO2 emissions per bushel that we're able to calculate just around nutrient management, so this doesn't include any changes in fuel use or any of those types of CO2 emissions, is about 34% reduction as we go from basic to advanced practices. So we're exceeding what some of the consumer packaged good companies are even looking for a percent reduction across their supply chain. Going a little bit more into that nitrogen use efficiency getting below 1 and the negative nitrogen balance numbers. So this is calculated a little bit different than the nitrogen use efficiency on the previous slide. This is from the International Nitrogen Expert Panel and their recommendations for where we should be on nitrogen use efficiency. but they calculate it slightly differently. They look at total nitrogen harvested divided by nitrogen applied, rather than the opposite of that, which we're looking at traditionally in US corn production of pounds of nitrogen per bushel of corn. But it's a similar idea, and you'll see that they've kind of established this desirable range for nitrogen use efficiency. And as we get out to 2017 in this example, we're seeing that they're getting into that risk of mining soil nitrogen. And so that can throw off our carbon and nitrogen balances in the soil and can limit or slow down our abilities to sequester carbon in the soil as we start to change that biological function of the system. We've also recently added some case studies working with the UW Discovery Farm program. So this is one of the Wisconsin dairy and corn silage. This is a 3,500 acre CAFO that is a permitted operation in Wisconsin. Bit more diverse crop rotation, adding the alfalfa in there. And they are using some custom application and injection of their liquid manure and high clearance applicators for their in-season nutrient applications. And so what we see here is a little bit different because we've got to look at this. We are actually able in these case studies to collect enough data to look at that sort of over rotation changes, which was very interesting to see. Here we see that on average per year cost increased with their more advanced 4R practices, and that was pretty directly related to the cost of injecting that manure. So there's a significantly higher cost when we handle manure in that way versus just surface applying it. So it's been a discussion in the dairy industry for a long time. What is that economic return as we add some of these practices into our management that are environmentally better and our nutrient management wise better, gives us an ability to credit our nutrients different, but can have a pretty high cost for adding a service like manure injection to a custom application. You'll also see that that price kind of goes up and down. So this is just looking at the average of the 4 fields over the 4 years for corn silage production. And you'll see that in 2016 and 2018, we have quite a bit lower cost. And so that is really the influence of that crop rotation and letting us be able to show that as we adjust for and credit for nitrogen from other crops, we are seeing decreases in our cost per acre. So this is to get a better idea a little bit of what that looks like. This is one individual field from that case study where you've got 2 years of alfalfa management and 2 years of corn silage management. And so in 2018, we've added some of those advanced practices like injection and a little bit of variable rate and some inhibitor products. But the biggest impact you'll see here is that because the farm is properly crediting for nitrogen from that alfalfa silage production, we're able to reduce that nitrogen application rate in that first year corn silage pretty significantly, which is going to contribute to potential decreases in loss is in that season because the nitrogen will be coming available from what's left in the soil from that alfalfa crop. So really nice way to demonstrate that farmers are crediting nutrients correctly. And with the subsurface application of manure nutrients here, they are pretty significantly decreasing that risk for phosphorus loss to the system. Finally, on the case studies, one last thing that we're working towards doing as we get more and more examples of individual crops across the case studies is what does this pattern look like across geographies for yield and reduction in greenhouse gas emissions or changes in nitrogen balance or changes in nitrogen use efficiency. And we're working on figuring out how to work with phosphorus and some of the tools available to look at water quality. But what we've seen is that across about the 13,000 acres that we've done case studies on for corn grain, with a yield range of 164 to 256 bushels an acre, that we have anywhere from a 10 to a 34% reduction in CO2 emission equivalents as we go from basic to advanced nutrient management practices. So I think that's some pretty good news for corn production in general. And all of these cases, as you'll see on the bottom, are either incorporating no-till or strip-till practices, which are practices that Soil Health Partnership is researching with farmers around what are the metrics of soil health that we're going to measure, and what are the economic performance of these practices at a little higher systems level. So again, 4rfarming.org is where the details of all these case studies live, and we have everything from chipped potatoes to corn silage on that website right now to take a look at and kind of see if there's something there that matches any of the practices that you might be considering on your own farm. So just to summarize a little bit, we're kind of trying to look at these metrics on a couple of different levels. So another program that I don't think I've got slides in here is our 4R certification program. So the 4R certification program certifies ag retailers, individual ag retailers, and the program is up and running in Ohio, New York, Florida, Minnesota, and Indiana. And we've got about 4.2 million acres that we can say are operated under the guidance of a 4R certified ag retailer. And so at that 4R certification level, we can start to measure how many acres we're reaching and some of these larger scale impacts of practice change on the landscape. Whereas in the case studies, we're really able to dig in, as you saw, to some of the detail of individual practice changes and how those are impacting economic and environmental metrics on individual farms so that we can help build the story at that larger 4.2 million acre level with our 4R certification. These are some other resources we have available. So nutrientstewardship.org is going to have general information on 4Rs. 4R farming is where the case studies live. And it'd be great to see some more followers on Twitter and Facebook. And with that, that is the end of my presentation.
Thank you, Sally. Please continue to submit questions in the Q&A box, and if time allows, at the end of our presentation, we will try to answer those questions. At this time, I would like to introduce SHP Field Manager, Lisa Kubik.
Good morning. I'm Lisa Kubik, and I'm the SHP Field Manager for Eastern Iowa. So I work with all of our farmers on the eastern part of the state. We actually recently released a business case featuring one of our SHP farm operations here in Eastern Iowa. The farm operation is owned by Roger and Wesley Zylstra, and I would like to share a little bit more about their SHP experience and what we've learned through working with them and putting together this business case. So a little bit more about the Zylstras. Roger and Wes, Roger would be the father and Wes is the son, farm around 700 acres near Linville, Iowa. In addition to growing corn and soybeans, the Zylstras also have a hog operation, which means that manure is an important part of their nutrient management strategy. Roger has always cared about being a good steward of the land, but also is always looking for ways to be more sustainable on their farm. But along with the sustainability, it's also very important that they maintain profitability and productivity on their farm. In 2014, they started experimenting with their own cover crops on a small number of acres and have planted cereal rye before soybeans that year. They felt they were seeing some benefits from the cover crops, but also wanted a little bit more specific data on what the impacts were on their farm. So in 2015, Roger and Wes joined the SHP and established a trial on their farm. Their goal was to take a look at cover crops and how the cover crops were benefiting their farm, but also how they were incorporated in their nutrient management approach. They chose to take a look at cereal rye due to its flexibility as a cover crop, but also in their situation, it holds up to disturbance of manure application when we're knifing swine manure into the ground, and also overwinters well and will provide a good ground cover in the spring. Over the course of their 5-year trial, the Zylstras have adapted many practices within their farming system to meet the unique needs of their farm. First of all, they've eliminated the use of fall anhydrous and incorporated spring, pre-plant, and side dress applications for all of their crops' nutrient needs. The goal here was essentially to make the nitrogen more available to the plant and reduce potential nutrient losses that could have happened from a fall nitrogen application. Next, they decided to adjust their cover crop seeding rate to control the amount of biomass that they would have in the spring. By reducing that biomass, they have less chance for the cover crop to affect their cash crops the next year when they go ahead and plant. And reducing the seeding rate also helps reduce their overall cover crop costs for their operation. They've also tried different methods of cover crop seeding application. To start with, they broadcast on their farm and followed with incorporation with tillage. To then establish better seed to soil contact and to increase their seeding or their stand, they tried some drilling on their farm, but ultimately have returned back to broadcast and vertical tillage to incorporate their cover crop seed. It seems to work better with the type of equipment they have available and the labor they have available on their farm. In the spring of 2020, they actually experimented with some planting greens. While they normally terminate at least 2 weeks before planting, this past spring, the weather was a little challenging and prevented Roger and Wes from getting into the field. So they ended up planting soybeans directly into a cereal rye field. As a result, Roger thought that they actually had better weed control in that field and thought the timing was more convenient because they didn't have to get out in the field a couple weeks before planting and spray. So they looked at experimenting with planting green a little bit more in the future. By being patient and adapting to these management practices along the way, the Xylostris have seen small changes add up to significant benefits on their farming operations. So one of the biggest benefits they've seen is utilizing the same amount of nitrogen and actually seeing a greater yields over this period of time. So they've seen increased use of nitrogen efficiency. They've changed the sources and timing of their application. While a liquid fertilizer program does cost a little bit more per unit for them, the nutrients are more available to the plant and more efficiently used by the crop and are placed where the crop it needs them when it needs them. Another benefit would be increased microbial activity. When we take a look at the soil tests that we've done on this farm, specifically centered around soil health, one thing that we have seen is an increased respiration on the farm, which is a sign of increased microbial activity also. Specifically, this has been seen on the cover crop portion of the Xylostris SHP field. When we look at how we can actually physically see this benefit on the farm, we're seeing an increased rate of residue turnover, meaning that we're not having as many stalks out in the field as much corn and soybean residue when we go back to plant the next crop. A third benefit would be improved soil structure. 2018 and 2019 were real wet years for this part of the state, and the Xylostris credit some reduced soil compaction during that time to the improved soil structure. When some of their neighbors were struggling to get into the field, Roger and Wes experienced less ponding, where they'd seen a lot of ponding in the past, and had less rutting and tracks left from equipment after the wet conditions. So as a result, small changes can make a really large impact on a farm. Roger has seen both environmental and economic benefits from his cover crop trial and plans to continue experimenting with different approaches to building soil health in the future. Roger's overall takeaway from his SHP trial has been that you don't have to have it all figured out when you get started. You can adapt along the way and make whatever changes it makes sense to make, but the best thing to do is just get started. So with that, I'd be glad to answer any questions. If you want to dig more into what this full business case has to offer and what we learned about the Xylostris and their farm, you can visit our website at soilhealthpartnership.org/Zylstra.
Thank you so much for attending today's Soil Sessions webinar. Our next session will be on January 19th, when we'll be sharing findings from a new farm finance report created in partnership with the Environmental Defense Fund. Please visit soilhealthpartnership.org to learn more and to get registered.